Good morning, students. Our today's topic in the topic of Newton's laws of motion. In this subject of mechanics A levels is the motion of the connected particles. So this is very important lecture. This is the last lecture of the topic. So concentrate yourself. Okay, in chapter 4, a number of the conventions were introduced. These, although not completely factual, made it possible to apply the principles of the mechanics to simplified situation, giving results that were acceptable. Okay, for the work that follows, we add further conventions that provide simple methods for solving the mechanics problems that arise in the topic. For instance, so from here the topic is going to be started, so concentrate yourself. For instance, we will refer to an inextensible string, that is a string whose length cannot alter, whereas in reality no string is completely inextensible. We shall also be dealing with smooth pulleys, that is whose bearings and rim are completely without friction. In practice, no pulley is completely smooth. Having said this, however, solutions based on these conventions can be fairly close to reality. Consider two particles A and B of mass ma and mb. So here is A, here is B of mass, okay, connected by a light inextensible string passes over a smooth fixed pulley, and suppose that ma is greater than mb. So A's mass is greater than the B's mass. So look now, as the particles move, one of the one of them moves upward in the same way as the other moves downward. That is, the upward speed of B is equal to the downward speed of A. So these are the deductions. So understand it and remember it. So when one body will move downwards and the one upwards, the upward speed of the body B is equal to the downward speed of the body A. This is one rule. Second is the upward acceleration of B is equal to the downward acceleration of A. And the third is the distance B moves up is equal to the distance A moves down. So first, remember these three rules. These will be applied when two bodies are connected through an inextensible string passing over a smooth pulley. Okay, the way in which each particle moves is determined by the forces which act on that particle alone. So to analyze the motion, we consider the particles separately. So the method to solve these kind of the questions, we will consider the two bodies separately, and we will check what forces are applying on these two bodies separately. So look now, here is the body A. Weight will act downward, tension will be in upward, acceleration will be in downward because A's mass is greater than the B. So A will move downward and the velocity will also be in downward direction. Okay, in second body, so velocity will be equal to velocity, but in this body, the velocity will be in upward direction because the mass of the body B is less than the mass of the body A. So that's why body B will move upward. So velocity will be equal. Okay, acceleration will also be equal. Its acceleration is in downward direction and B's acceleration will be in upward direction. Okay, weight of the body B will move in downward direction and the tension in the string will be in upward direction. So here is a question in this topic. So concentrate, that will make your concepts more clear. A particle A of mass 10 kg is at rest on the ground. So this is the body of mass 10 kg that is resting on the ground, is attached by a light inextensible string passing over a fixed smooth pulley to a particle B of the mass 4 kg. So this is B whose mass is 4 kg, that is connected through inextensible string passing over a smooth pulley with 10 kg mass. Okay, A part is the tension in this string, and the B part is the force on the A exerted by the ground. So the things to understand is this body's mass is 10 kg and this is 4 kg. So ultimately this will not be pulled up, but there will be tension in this string because of this body whose mass is 4 kg. So in A part, the tension of the string is the requirement, and the second is the force on A exerted by the ground. So concentrate yourself, we are going to solve it now. So we will discuss two bodies separately. So this is the method to solve these kind of equations when the bodies are connected through extensible string passing over a smooth pulley. So you will discuss the bodies separately. So look now, here is the body B and here is the body A. So now for body B first. The forces acting on B are its weight and the tension in the string, because the body is hanging through inextensible string. So weight will act downward and tension in the string will be upward. So it means tension will be equal to the weight. So T is equal to 4G, because 4 kilogram is the mass of the body. So T is equal to 4G. G is 10. So the tension in this is the same throughout the string. So the tension in the string is 40 Newton. So if here is T, that is 40 Newton, so the tension on the body A through the string will also be 40 Newton. Okay, in second part, it was required that what is the reaction of the earth that is putting on the body A. So look now, the forces acting on the A are its mass, the tension and the string. Because the weight will act downward, reaction will be in opposite direction, and also there is the tension in the string. So R and T are in the same direction and weight is in the opposite direction. So T plus R will be equal to W. So look now, T plus R is equal to W. Okay, tension in this string is 40 newtons, so that will be placed in place of the T. R is the requirement and weight is 10 G. So G is 10. So 10 into 10 will be 100. So 100 minus 40 will be 60. So this is the reaction, that this is the force exerted on A by the ground is 60 Newton. So this is the solution. Here is another question. A light inextensible string passes over a smooth pulley, fixed pulley, and carries particles of the masses 3.5 kg and 6.5 kg. So these are the masses of the two bodies which are connected through inextensible string passing over a smooth pulley. The masses are 3.5 kg and 6.5 kg, one at each end. If this system is moving freely, find A part the acceleration of each particle, B part the tension in the string, and C part is the force exerted on the pulley by the string. So concentrate yourself. The masses are 3.5 and 6.5. Okay, here is the solution. So concentrate yourself now. The two particles have the same acceleration. So because the acceleration and the tension will be same on the two portions of the string. The two particles have the same acceleration A meter per second square, and the two parts of the string have the same tension T newtons. So we are discussing separately the two particles. So here is particle A. Weight will be 35 Newton. That will act downward, and in upward direction there will be tension. Acceleration will also be in upward direction because mass is less than the other one. Here is the body B. The weight will act downward, tension in the string will be upward. These two tensions will be equal, and its acceleration will be in downward direction, but the acceleration will be equal because the two particles have the same acceleration and two parts of the string have the same tension. So look now, we are going to solve it now. As far as A body is concerned, because the A body will move upward, it means the tension will be greater than the weight. So T minus 35 is the resultant force. So putting values into this formula, this is the resultant force, T minus 35. M is 3.5 and A will be here. Now for body B, because the body B will move downward, so that's why weight will be greater than the tension. So that's why 65 minus T will be the resultant force. Formula is used, we are using this formula, F is equal to MA. This factor will be put in place of the F. M is 6.5 and A is still there. So because the tension is same and the acceleration is also same, there are two methods. You may equate T in both equations, or you may solve these two equations simultaneously. T will be cancelled and A will be left. So for A part, look now, here is the solution. So adding 1 and 2, so A will be obtained. Okay, in B part, it was required that find the tension in the string. So this is connected part. So because A has been obtained, you may put the value of A in either of the equations. You may put it in equation number 1 or in equation number 2. So this is equation number 2 and this is equation number 1. So put A's value over here or here. You will get the same answer. That will be T. So this is the tension in the string, because tension in the two portions of the string will be same. Okay, now the C part is the force exerted on the pulley by the string. So concentrate yourself. This is even more complicated part. So we are going to solve it now. So you can see here there are two tensions applying on the pulley. One through this portion of the string and one through this portion of the string, and two tensions are of equal measures. So look now, the string exerts a downward pull on each side of the pulley. Therefore, the resultant force exerted on the pulley by the string is 2T, because here is T, here is T. So 2T is the force that is acting on the pulley. Okay, that is 2 times of the T that you have find out in B's part. So put this value of T in place of T. So 2 times of 45.5 will be 91. So the resultant force on the pulley is 91 Newton downwards. Here is another question. A small block of the mass 6 kg rests on the tabletop. So this is a mass of 6 kg resting on the table and is connected by a light inextensible string that passes over a smooth pulley fixed on the edge of the table. So here is the edge of the table. To another small block of mass 5 kg which is hanging freely. So here is 5 kg mass. Find in terms of G the acceleration of the system and the tension in the string. So two things are the requirement: acceleration and the tension in the string. A part when the table is smooth, and B part when the table is rough and exerts a frictional force of 2 G Newton, where G is actually 10 meter per second square. So this is the thing. So first we are going to solve A part when the table is smooth. So it means when the table is smooth, there will be no frictional force that will resist the motion of the body. So look now, we will solve two particles separately. So look now, for the particle A, there is no frictional force. So it means T is the only resultant force, that is the tension in the string. So this is the resultant force, will be equal to MA. So T is equal to 6, because this is a particle of mass 6 kg and this is a particle of mass 5 kg. So F is equal to MA, T is the resultant force, equal to M, that is 6, and A is still there. So this is equation number 1, that is block A's equation. Okay, now for block B, because block B is moving downwards, so it means the weight will be more than the tension. So it means 5G minus T is the resultant force, will be equal to MA. M is 5 and A is still there. Okay, this is the equation for block B now. From here you may solve these two equations by equating T. So you will get A, or there is another method. You may solve equation number 1 and 2 by simultaneous method. So when these equations will be added, 5G will be equal to 11A, and from here A will be equal to 5G over 11, and okay, this is A. The second requirement is the tension in this string. Now you may put this value of the A in either of these two equations, equation 1 or 2, answer will be same. So when you will put this value of A in this equation or in this equation, So the answer of the tension will be 30 over 11 g. So the acceleration is this one, 5 by 11 g, and the tension in this string is 30 over 11 g. Okay, the second part was when the table is rough and exerts a frictional force of 2g Newton. So concentrate yourself. Now the another force will be applied. So again, we will solve separately the particle A and particle B. So for block A, because the body is moving towards right, so it means the tension will be more than the frictional force. So T minus 2G, that is the frictional force. So T minus 2G will be the resultant force, is equal to MA. M is 6 and A is still there. So this is equation 3 that is obtained for block A. Now for block B. So block B is moving vertically, so in downward direction. So it means the weight is more than the tension. So 5G minus T will be the resultant force, is equal to MA. M is 5 and A is still there. So these are two equations. Again, you may solve it simultaneously or equating T. So when you will add 3 and 4, T will be cancelled and 3G will be equal to 11A. And from here, A will be equal to 3 by 11G. Okay, here is the A's value obtained. Now you may put this value of the A in either of two equations. Answer will be same. So when you will put this value in any one of the equations, so T will be 40 over 11G. So the acceleration is this one and the tension is this one in second case. Here is another question. A particle A of mass 2 kg. So A's mass is 2 kg, rest on the smooth plane inclined at 30 degrees. So smooth, so it means there will be no friction. Okay, 30 degree is the angle of the inclined plane with the horizontal. The particle is attached by a light inextensible string passing over a smooth pulley fixed at top of the plane to another particle B of the mass 3 kg. So B's mass is 3 kg, A's mass is 2 kg. Okay, find A part the normal reaction between the A and the plane. So normal reaction is the requirement. B is the acceleration of the A is the requirement, and C part the magnitude of the force exerted by the string on the pulley. So C part will be somewhat different and important. So because the resultant force will be applied exactly between these two forces. So concentrate yourself. We are going to start now. So concentrate yourself. We are going to solve the question. So for A part, the reaction of the inclined plane is the requirement that is putting on the particle A. So look now, A does not move perpendicular to the plane, so the resultant force in this direction will be 0. So because the component that is vertical to the plane will be W cos theta, that will be exactly in opposite direction of the reaction. So R is equal to 2G cos theta, that is W cos theta, because mass of particle is 2 and G is that is 10. So W cos theta, theta is 30 degree that the inclined plane is making with the horizontal. So solve it on the calculator, you will get this answer. Okay, this is the normal reaction between A and the plane in 17.3. Okay, now the second requirement is the acceleration of the body A. Okay, because for body A that is moving upward and the plane is smooth, there will be no friction. Okay, this is the important point to be noted. The inclined plane is smooth. The only factor which will oppose the motion is the component of the weight that is acting parallel to the plane. So it means tension in the string minus W sine theta should be equal to MA, because this is the resultant force which is acting on the A along the plane. So T minus W sine theta is equal to MA. M is 2 and A is still there. Okay, this is for particle A, and for particle B. Particle B is hanging vertically. So the weight of the body is more than the tension because the body is moving downward. So 3g minus t will be the resultant force is equal to ma. M is 3 and a is still there. So solving these two equations will give you the answer A. So this is the acceleration of A. Okay, the last thing that was required, the force acting on the pulley. So again, look, the inclined plane was making an angle of 30 degree with the horizontal. The vertical angle was 90 degree. So the angle at the pulley will be 60 degree because the sum of the angles of a triangle are 180 degree. Listen again. The inclined plane is making an angle of 30 degree with the horizontal. The vertical is making an angle of 90 degree with the horizontal. So the third angle that will be at the pulley will be 60 degree. So look now, this is important point to be solved. So first we will find the tension in any one portion of the string. So putting this value of A in any one of the equation number 1 or 2, that will give you the answer of the T, that is 18. So look further now. So this is the important thing now. This string exerts two equal tensions on the pulley, one in this direction and one in this direction. So the resultant force on the pulley bisect the angle between these two tensions. So here will be the resultant. So this angle is actually 60 degree. So that will be R will be equal to 2t because here is 1t, here is second t. So 2t and bisecting the angle here will be 60 degree. So that will be 2t cos theta. So R is equal to 2t cos theta. So t's value is 18. So putting this value over here and solving it on the calculator. So this will be the answer. Here is another very important question. So look at this statement. Two particles of masses 1 kg and 3 kg are attached to the ends of the long light inextensible string which passes over a fixed smooth pulley. The system is held with both particles hanging at a height of 2 meters above the ground and is released from rest. The particles start to move and the heavier particle hits the ground but does not rebound. Find the greatest height reached by the particle of the mass of 1 kg. So two particles 1 and 3 kg are hanging. Okay, now we are going to solve it. So look now, here is the solution. Until the 3 kg mass hits the ground, the masses move as a simple connected system. So for 1 kg mass, because the 1 kg mass is moving up, so it means tension will be greater as compared to the weight. So the net force will be T minus 1g is equal to MA. M is 1 kg, so 1A. So this is the equation for 1 kg mass. So now the second mass is 3 kg mass, because in this kind of question we discuss the particles as the separate systems. So first we have discussed the 1 kg mass and now we are going to discuss the 3 kg mass. So for the 3 kg mass, because 3 kg mass is going down, so it means weight will be greater than the tension. So 3g minus t will be the resultant force is equal to MA, and M is 3 kg, that's why 3A. From here you will add these two equations, so t will be subtracted and 3g minus g will give you 2g is equal to 4A. And from here A will be equal to 2g over 4, so that will be equal to 5. So this is the acceleration with which the 3 kilogram mass is moving down and 1 kg mass is moving up, because the acceleration will be same in the two portions of the acceleration in the two portions of the thread. Okay, for the motion of the 3 kg mass over a distance of 2 meter, we have u is equal to 0 because the system was initially at the rest position, so initial speed will be 0. Acceleration we have just find, that is a is equal to 5, and distance has moved, that is 2 meter, because it was given that is that the system is 2 meter up the ground. So s is equal to 2. So using these values, we are going to put this equation, that is the third equation of motion. So v square minus u square is equal to 2as. Now putting these values into the equation will give us the value of v. So this is the velocity with which it will struck the ground, and this is the same velocity with which 1 kg mass is moving up. Okay, look now. Once the 3 kg mass hits the ground, the string becomes slack and no longer exerts any tension on the 1 kg mass. This mass therefore moves on upward with an initial speed of this speed, because this is the speed of the both particles at that moment. So that will become the initial speed under the action of the weight alone, that is with an acceleration of the minus g, because 1 kg mass is moving up, so acceleration will be negative. When it will reaches the greatest height, its speed will be 0, so it means final speed will become 0. So it means u is square root 20. That was the final speed of the that was the speed with which the particle was moving. A is minus 10, free fall acceleration. Negative will be shown that that the body is moving up, and final speed will be 0. Okay, again using the third equation of the motion, putting values into it, so we will have s is equal to 1. So be very careful now. So because this is the point which is very important, the 1 kg mass rises a distance of 1 meter above its position when the string went slack. So it means because the 3 kg mass will move 2 meter down, so 1 kg mass will move 2 meter up, and in the beginning the system was already 2 meter up the ground, so 2 meter up means it is 4 meter up, and when the string becomes slack, it has moved 1 meter more up. So the 1 kg mass rises a distance of 1 meter above its position when the string went slack. As this point was already 4 meter above the ground level, the greatest height reached by the 1 kg mass is 5 meter above the ground. So this was the question, students. This was the lecture. Read this lecture again, understand it, practice it, and make your notes. Thank you so much.